Uh, well, right now I have up a 50-foot tower. And going from 50 feet to 70 foot, you're 3 times more likely getting struck by lightning. Yeah. But
So-
anyways,
Is that analytical or is that just by experience?
that is by other people's reports. And actually, it's in the ARRL grounding book and that. They have a graph there that shows number of lightning strikes per year versus the height of an antenna.
Oh.
So anyways, gonna look at my grounding system there, and it's got some very unusual problems to it, which may catch you by surprise. Noise and common mode currents, which again will maybe catch you by surprise.
Is there a way of checking to see if you got a good ground? I got an 8-foot ground rod driven into the ground next to the house. But it seemed like it went in awfully easily.
Oh.
Yeah, I'm not sure if it's going over the net, but anyways, the question is there a good way to check the ground? And actually, the next slide after this, you'll see some very interesting information. So anyways, look at my grounding system, noise, common mode. Gonna look at my grounding system here. Wait, I thought I changed.
The bottom one?
That's the one I'm hitting. Maybe
Okay.
I need to point it the other way.
No. Hang on.
This bottom one right here, right?
Yeah. Okay. Oh, there you go.
Okay,
You may have to change it.
and then we're gonna look at some lightning protection stuff. And the guys at the remote station, this may frighten you.
Oh, great.
Yeah, just what you need is getting frightened. But anyways, gonna talk quite a bit about what's known as ground potential rise. Because the ground is not this infinitely good conductor. And you get a lightning strike, voltages go up all over the ground. And going to look at some published data on lightning strikes. And we're going to look at some simulated stuff in that, mathematical stuff. And also some of my personal experiences there with lightning. So anyways, ground systems are a whole lot more complex than what you would normally think. You know, Mark, you say single point star ground, right? Well, here's my grounding system. There at the incoming power, there's a ground rod. And connected to the ground is my neutral wire, which is 300 foot long, 250 MCM aluminum wire. Yeah, what could happen there?
Well, that's a big inductor. So it's virtually invisible to the lightning because it's going to be so high impedance.
Maybe.
Ah,
But anyways,
I'll just throw those ideas out there.
yeah, absolutely.
Includes the light strike anywhere.
well, I see a ground, there's a ground loop in
Okay.
there too, right?
Doesn't matter where you.
Yes.
The lightning.
And
So does that just go around in circles forever?
it could, but anyways, there at my breaker box, it is required by law to have a 8-foot ground rod.
Oh, it is.
Yes. And actually, just a quickie on that one there, my son is down in Alabama now living in a box truck. And he had a 250-foot extension cord going to his box truck to the power line. And guess what? He didn't have a ground rod, and as he's getting in the truck, he was getting a poke. So guess what? At your breaker box, required by law, you have to have a ground rod.
Yeah.
And the other thing is we forget about the wiring in the house. I did a quick estimate and I probably have got 2,000 foot worth of wire running through the house. This is number 12 wire,
Exactly.
acting as a great big antenna. And there's the ground wire and there's the neutral wire, all connected to that star point. And so anyways, the 8 foot ground rod may not be very effective, but it's also connected to my water line. That's 1 inch copper water line, about 300 foot long. So anyways, that makes for a pretty good ground. Yes,
So you have one ground rod on the left side of your drawing. And your copper water line is a distributed ground, nice 300 feet of copper buried in the
Yep.
ground. Okay.
so anyways, that copper line there is basically 6 foot down and 300 foot long.
Yeah.
Well, then going over to the radios. Guess what? If you have anything that plugs into the wall, guess what? You've got a ground connector. You have a 3-prong plug, which connects it back to the breaker box. And then going out of where the radios are, my RF ground, that one there happens to be some 2-inch EMT pipe that goes out to a junction box, which again is tied to the water line. It is also tied to a ground rod at the bottom of my 50-foot antenna tower. So what do you think about single ground points?
You don't exist.
They basically don't exist. And anyways, going out to my 50-foot vertical, that used to be a 70-foot antenna tower. And at the base of the antenna tower, I've got 3 or 4 different 8-foot ground rods. And also I used it on 80 meters all the time. And actually that's my 80-meter antenna right now. I've got about 30 radials, 30 feet long. So almost 1,000 foot of wire buried in the ground,
Wow.
which ought to be a great ground. So anyways, that's my setup. And I'm really going to focus on going from the J box out to the 50-foot antenna tower. And you were asking, well, gee, can you measure the ground? Well, let's see. Yeah,
Not working again.
not working. Next.
See,
Okay. So anyways, here's what we got. The other thing that's bad is we got a rocky ridge going between the house and that other antenna system. When I built the house, it took 430 sticks of dynamite to put the hole in the ground. Are you starting to see some of the problems?
Yeah.
And so anyways, again, we got the ground at the junction box just outside the house. So if you want to hit the next one, since this one's not working. So anyways, again, how do I check the ground? Well, I took an ohm meter and I knew it wasn't going to work. In one direction, it read 850K, which is not right. In the other direction, it was 0 ohms, which is not right. So guess what? I said, well, what's happening here? Well, I measured some voltages. The DC volt to ground, when I first did it, which was about 3 weeks ago, when Mark asked me to work on this thing, was 0.068 volts. And luckily I had done the measurements before we had that heavy rain. couple, or actually week and a half ago. After the rain, it was, after the rain, it was 0.086 volts.
Hello,
Yes,
you said you measure DC volts, you measure from your ground reference, and where's the other lead?
okay, I disconnected the 80-meter vertical, so between that coax going out to the 80-meter vertical to the ground box was 0.068 volts. The other thing that gets even more interesting is that if you look at the AC volts, the AC volts was 0.16 before the rain and 0.37 after the rain. So obviously, the ground conductivity changed. Thoughts on that one? Yeah,
I think it would be the other way around.
Yeah, exactly. That's what I was,
okay, the other way around,
The question.
voltage would go down because of the moisture from the rain.
right? It all depends where the garbage is coming from. If it's coming from outside my area, you'll have better conductivity to the grounds.
Yep. Okay.
Yeah,
So
George,
I'm curious, when you measure the voltage between your neutral or your 3-pound plug and the ground,
mhm.
what do you get?
Okay, what I was measuring was I disconnected that 200-foot hardline coax going out to the vertical antenna. So between the shield on that hard line and the ground at the junction box is where I was measuring.
I'm curious if you measured the other.
Well, okay, the other way from let's say,
Neutral to ground, because I sometimes get a pretty good voltage difference between neutral and ground.
yeah, actually, I did not do anything with the neutral. This is all strictly RF that goes back to that diagram. Well, actually, if you want to go back about 3 slides or so. I could try and see if one more.
One below it. There you go.
Okay, what I did is I disconnected this coax here and I measured from this point to this point right here. So really from ground to ground.
Oh, interesting. Yeah, I'm glad you showed that. I was curious.
Yeah. So, again, would you expect that?
And
Actually,
you still have this end connected to the antenna?
yes, this end was connected still to the antenna.
So are you measuring what the antenna is picking up also? I mean,
Maybe.
is that contributing?
Maybe, but would you think that if it was coming from the antenna, would it change with the rain? If you want to go back to that other slide that we were on.
So like if you had if you were near an AM broadcast or something and the vertical picks that up and it would get coupled into the ground and add voltage, is that what you're thinking? Something like that?
Well, I'm just interested to hear.
Yeah, I'm dying of curiosity.
Yeah,
You get me.
sure. There's a few different things. When you talked about the rain, it should have changed. Water propagation to the grounds takes a while.
Yeah.
And if you got funky soil and stuff like that, I'll add to the issue. Another thing I can't help but think about is what's the bandwidth of AC corridor?
Yeah, and
Yeah, good point.
actually, if we go to a couple more slides,
Try it, Larry.
okay,
Can you look at it on with a scope and see what the waveform looks like?
there we go. Okay, those are the voltages. Okay, and you had a question?
Right, from my very limited experiences on grounds, so that, to verify grounds, it's pretty tricky business, but another thing is that because the water gets into the soil.
Yep.
you Could have some electrochemical reactions going on that could affect these readings, right?
Absolutely. And actually, the DC voltage is probably dissimilar metals
Yes,
in an electrolyte.
yes.
And I've always sensed that kind of stuff whenever I try and measure voltages from a ground.
Now that would explain the first line, which looks like a diode.
Yes. And when you measure with a ohm meter, you're basically putting a DC voltage on something
Yeah.
and measuring the current.
Yeah.
Well, Mark, you were asking, well, what is the bandwidth? Oh, okay. Another way of measuring the resistance was I used a 24-volt transformer, AC, and measured the current. And so I had 14 ohms resistance at 60 cycle before the rain, 9 ohms after the rain. So the conductivity did improve.
It did, yeah, that kind of. Yeah.
Yeah,
In the,
Yeah.
Go ahead. I didn't have my hand up.
And there also could be another thing is that different types of ohm meters sense resistance differently. Some you have a constant current and then look for voltage drop.
Yep.
And of course, if you have any other electrochemical reactions entering into that, it's gonna add like batteries being stacked in different places at different
Yep.
times. So there still could be a lot of little details fooling just.
a lot of little things that are happening here. And I think you had a question.
Well, not so much a question, a comment. I was on the Adams Jeffco hazardous materials team. We did a lot of bonding and transferring of chemicals that were very, very flammable.
Yes,
And we would do three grounding rods, and then we poured Gatorade into each one of those holes.
an electrolyte.
An electrolyte into each of the holes to increase its bond.
Wow.
Incredible.
Yep.
What flavored Gatorade worked best?
Yeah, I,
It didn't matter.
Yeah.
Red or green.
Yeah.
Or it was on sale.
So
We always
anyway,
did that. We always put
Right.
electrolytes in the holes.
Yeah,
That's amazing.
when I worked at Lockheed Martin, back in the eighties, nineties. We were building a new electronic manufacturing facility, and they were really hung up about the ground.
Yep.
And part of what they had to do, and of course, that, if you know where that facility's at, it's kind of back in the hogbacks.
Yep.
By Roxborough Park. They had very variety of different, their ideas of trying to make a good grounding, central point ground rod. And they ended up having to make it so that they had to pour water down it eventually every once in a while to keep it from drying out and causing
Mhm.
groundings to start forming.
and I live in just behind the hogback. So I've got a similar kind of problem.
actually, you're pretty close to Lockheed Martin as far as that
Absolutely.
rock across.
Yep, I'm just north of it.
So is this calculated resistance?
Well, actually, you have to calculate it from volts and current.
No, but I mean, it was, you weren't, yeah, okay.
So, you measured it the old fashioned hard way, put 24 volts on it, measure the current with a clip-on amp meter, divide stuff out, and you notice what happened. And Mark, you were asking, well, what is the frequency domain of that AC voltage? Guess what? There we go.
Wow, there was a lot of.
There's a lot, and this happens to be on the 200 millivolt scale. And what is interesting is there's a lot of RF there, but notice the 60 cycle that's in there also. It's very dependent on 60 cycle. And again, after the rain, notice what the pattern looks like. You got a higher voltage. are you conducting more garbage into your ground system now?
Oh, boy.
Thoughts on that one? And guess what? It's gonna get even more interesting.
That's what Mark Err is trying to talk over the lower right.
What's that?
Lower right says Mark Err is trying to talk.
No, that's just the computer.
That's just his
Oh,
login
okay.
here,
Yeah,
Larry.
Mark from here.
Okay. Well, anyways, the next question is, okay, we got voltage, what kind of current do we have? So, I hit the wrong way, sorry. So anyways, I happen to have a flux probe. And basically, it's just an inductor that measures the field coming, around a conductor, converts it over into voltage. And it goes up, it's linear response. It's linear response up to about 10 kilohertz. The higher the frequency, the more voltage it generates, just like a typical coil. And after about 10 kilohertz, it falls off. So would not expect to see much above 10 kilohertz. So what does the pattern look like there? That was before the rain, that is after the rain.
Major difference.
Quite a difference. But notice the spikes,
Yeah. Mhm.
a minus spike and a positive spike. Again, 60 cycle related. And so anyways, if you take your incoming power and you put it on the second channel, notice that those spikes match up perfectly with what the incoming 60 cycle power is.
Yep.
Do we have a bad insulator there, or what the heck is happening? I've got a problem with line noise I've never been able to find. So anyways, here's a close-up of the thing. And there's the spike, there's some of the oscillations and how they take place. And further down the road, what I'm going to do is I'm going to measure things at a higher frequency and see what I can see.
What's your instrument that you're using? It says Bayonet.
Okay, this is a dual trace 200 megahertz storage scope.
Oh, wow.
And actually, I got it at a great deal, brand new. I think it was just over $200 many years ago. But it's been the handiest thing ever. And you can do fast Fourier analysis on the thing. You just have to press a button and you save it to a jump drive. So that becomes real easy. So one more. I think some key questions is the noise that I'm receiving, is that due to something like a bad insulator? Is it voltages that are being conducted in the ground? I don't know. Or is it coming from a radiating source? And again, if you look at Maxwell's equations, wherever you have a current, you got a electromagnetic field, and where you have an electromagnetic field, you got a current. Yes.
Just a thought. You're so good about putting down grounding rods and, grounding plumbing and stuff like that. Is that whenever there's a difference in conductivity between each one of these ground points, and depending on where you measure it, you could end up with a ground loop in those different areas, almost different grounds.
Absolutely. And so anyways, we've got huge amounts of ground loops with large amounts of area.
And it depends on what is being injected into the ground plane.
Yep.
And where, and the conductivity between there and the next ground reference.
Yeah.
Am I getting this right?
Absolutely. And if you think it's simple, you don't understand the problem.
Didn't you have them, they check the lines already for the insulators?
Yeah, actually, the lines north of us, they just recently replaced them. So that is brand new lines. The noise level has not changed. There's a couple of laterals in that could be causing the problem.
You've had a noise level since you moved there.
Yep,
Do you have underground utilities or is?
yes, I have underground utilities. here.
Wow, because that's what I was thinking. Don't remember
So-
seeing any.
You know, you go back to this thing here. You know, obviously, it's probably coming from some sort of discharge. As the voltage goes up, you got a discharge, you got oscillations, and you got the discharge on the opposite voltage. Yes.
Also occurs to me that you also could have some interactivity between that and the neutral conductor.
Oh, yeah, you will, and an experiment I did a long time ago was use the flux probe on my water line, and I could see when you flipped on a fluorescent light. But this is way past the neutrals in that, and really it's between a ground next to the house and the ground out there at the vertical.
So, Larry, for our remote station, you're recommending us not taking a ground strap from the tower and bolting it into a rock?
Uh.
They're the
I'm gonna get
rocks.
to that.
We'd have to haul one in.
I was gonna say Strasburg has rock.
Yeah. Jim, the next half of what I'm gonna talk about will probably scare the hell out of you. I'm sorry, but.
I work with students, nothing scares me very much.
Hilarious.
Oh, and I guess one other test I've got here is that common mode noise causing a problem in the receiver? And so what I did was I took the little G90 and I measured it in the shack, what the noise floor was. Then I took it out to the antenna so that there was no interaction with the grounds and there was no perceivable difference between noise in either place. And so the ground loop was not an issue. And again, this is hardline, so you got a solid aluminum outer shield. And so, the coverage is 100%. Questions on that one?
Yeah, I've done a lot of instrumentation stuff and real delicate, super sensitive stuff. It's really bizarre thing dealing with voice. But is there a possibility that you could, instead of configuring the way your setup is in your house, I mean, yeah, it's kind of fun. You got a lot of different ground sources and potential impedance differences between each of those relative to each other.
Yep.
Is there a possibility that you could set yourself against one ground and make a radio ground setup? In other words, you've got all these different grounds. I mean, that's great, but at the same time, to eliminate this noise, having only one ground reference for the whole system,
Yep.
the antenna and your receiver and the electronics associated with that, is that possible? And that shouldn't that eliminate this kind of noise?
And actually, that was one of the things I tested here was that what if I took the receiver straight out to the antenna and only the ground at the antenna? And there was no significant difference between the noise levels.
You've had a noise level since you moved in there.
But couldn't that also be linked through the neutral?
Actually, out there would not be a neutral unless that noise was coming down the down to 200 foot of hard line. But again, that was disconnected.
Well, you're still powering things up.
He's on a battery, I
The
bet,
neutral line,
right?
the neutral line's grounded to your J box.
Actually, I was powering up the receiver at the antenna with the battery.
With hard was.
So anyways, there was no possibility there.
I don't know what I'm talking about.
Oh, please ask
No, that's,
Please.
valid questions. And that's how I know I'm doing some communicating is, what the hell is he talking about?
it is interesting that the ground floor, your noise on the receiver didn't change.
Yeah.
That's, I almost think that's more of a surprise than anything.
Yeah,
Well, does that tell you that it's coming in to the antenna?
Yeah,
From the-
that's what
I don't know. And again, could I be pumping RF into the house or something like that? But I can't find it. And so would I be better off trying to measure different places, with a couple of ground rods or a couple of capacitors to ground and seeing where the noise is the greatest? And possibly trace it down that way.
What does that do to your white supply appliances then? You don't feel it in appliances at all? The stove, the microwave, the whatever you have in the house. Your wife doesn't complain about that
Oh, no.
always?
No, and actually the noise level is reasonably low. Right now I'm sitting at an S5 noise level on 80 meters. And I've been able to work all the zones except for 3. So anyways, no problem getting into, the Indian Ocean and places like that on 80 meters. So it's not bad, but it's not good.
Got it.
Now, I presume you've started with the old trick of turn the power entirely off.
Yeah, I was wondering.
Yes,
Yeah.
yes. And if we have a power outage,
The whole neighborhood then is
Yeah.
quiet.
okay, and then the K3 does show a good drop in noise. And it
So-
does vary with the time of year. So,
And you still have noise.
and I still have noise.
Now, when you turn the power off. When the neighborhood, when there was normal power.
Yeah.
And you turned your house power off.
Yeah.
Did it go quiet or?
Okay, when I turn my house power off, there is virtually no change in the noise floor.
So it's coming from outside of your
It's
house.
coming from outside the house.
But when the neighborhood goes dark.
Yep.
It's quiet.
It's much quieter.
Wow.
And I think you had a question back there.
I think you just need to get rid of your neighborhood.
Yeah, right. We need to move.
Eliminated.
I see. Round rod along the line that say how.
He lives right, yeah, he lives right by.
Okay, look, you're looking at the wavelengths of the various things.
Well, it would have reduced the noise if you had ground rods spaced
Oh, yeah,
along that line instead of one at each end.
and roughly 200 feet, that's about 60 meters. It tends not to resonate with much of anything.
So when the neighborhood goes dark,
Yep,
is Lockheed Martin dark?
I don't know. Probably not.
They generate.
That's a really
Yeah.
good point.
Yeah, that's true.
That's
Sure.
where it comes from.
By the crow flies, how far are you from Lockheed Martin?
3-4 miles.
Yeah.
And I'm probably a mile and a half from the Lockheed Martin Aerospace facility across the street.
And at 80 meters, that's next door.
Yep, it's next door.
Yeah.
Well, let's sort of summarize where we're at. Grounds, there's no ground that's perfect. It has significant resistance. And it may not be a good dumping point. And I believe that the ground can conduct noise. That's a belief.
Yeah.
Now let's get to the frightening stuff.
Feel that. Power lights.
Ground potential rise. Story I've told before is that in our Richmond, Indiana plant, they were dumping a load of, call it And anyways, the dump truck's bed hit the power line,
Oh, wow.
12,000 volts. And anyways, the tires of the truck started on fire. We had a young engineer grab a fire extinguisher to put the fire out. And he never made it to the truck. He was electrocuted.
Never made it to the
What's that?
He never made it to the truck.
He never made it to the truck. And then we're gonna look at some of these things, why? And Larry, I know you've had experiences like that, they're at Excel.
Yeah, ours was a little different. The dump truck is backed up into one of our lines.
You know,
And he jumped out of the cab and came running over. And it was, people were yelling at him. And he turned around to look. Then after a while, the tires started smoking. Then he thought, oh, I've got to get that out of there. So he ran back to the truck.
He did make it.
He made it all the way to the truck. He got his hand on the handle of the truck, and that's when it fried.
Yep.
And the reason is that happens is the rubber tires on your car or truck are not true conductors. It's not like you have a ground rod on the truck to ground. So what happened is the amount of current that was going through the truck, through the tires to ground was less than the fuse. So the fuse goes, oh, someone turned on a little load there, huh? It doesn't do anything because it doesn't see any overload. But the tires have resistance. They're not the perfect ground. They're not a perfect insulator either. They're the semiconductor. And that means that they're conducting current. And if you're conducting current through a resistance, you've got a power being generated. And that's where the electricity going through the truck tires are generating a lot of heat. And finally, the heat reaches a point where the tires turn combustible.
Yep, and again, that steel belt in them makes a pretty good conductor.
Yes,
And you
but,
know,
but the steel belt in the rubber tire is not connected to the hub of the hub. It's around the outside. So the sidewalls are generally where that heat is being generated. And that's why when you see these situations where there's big storms and people run into the lines and the lines draped across their car and everybody yells, "Stay in the car." Now, if you can, you'd like to get out from under the wire because it could be going through the rubber. If you have a good ground and the line comes down and the amount of current being pulled from the line to ground exceeds the fuse, and the fuse will blow and de-energize the line.
But now they have reset, the fuses reset themselves.
Yep,
Well, it depends, yeah, and it depends on whether you're talking a fuse or a reclose.
Yes, you can't trust the fuse.
Yeah, because some of them are fuses and some of them are actually automated circuit breakers. To give you an example, is a rough estimate of what. And that's why your lights blink when you see an outage.
the scary thing is,
He's talking about.
Yep.
Is the recloser, if the line shorts, the recloser opens and then immediately shuts. What it's doing is, it's assuming a lightning strike or some intermediate short to ground, it opens up and the air deionizes wherever that arc is. Then it shuts back in. Well, if it's some arc caused by, say, a lightning, you open the line up just momentarily and shut it. It gives the air in the arc time to deionize, and then it won't restrike, and then your fault's gone.
yeah, another logic with that is that a branch hits the power line. You should have enough power there to vaporize the branch. And so I think they're typically set for 3 reclosure tries.
Yeah, depends on protection scheme, because you can have fewer or more. You can actually, there are very few. And usually in rural places where you have long extension line, you could have up to 4,
Oh, okay,
but 3 is the normal. At least, excuse me, 3 is the normal as of 20 years ago when I.
Yeah.
Was I,
So it doesn't keep retrying though. I mean, there is a finite number of retries.
yes.
right,
I've been on scenes where they constantly re-energize. I mean, it's just a regular circuit. You have to stay away because it's just constantly reset
Wow.
until the power's turned completely off.
Oh, wow.
So, just because it's not sparking anymore, doesn't mean that it's dead.
Yeah, exactly, exactly.
just to the side, which doesn't necessarily have to do with grounding, but you see this deal on TV, so, well, I heard an explosion. That's normally a fuse. When a fuse blows, that's interrupting 7,000 volts.
Son was killed.
It's a,
Hitting ball.
has a sound of roughly equivalent to a 12-gauge shotgun.
One of the culprits.
Oh, interesting. Okay.
Yeah.
I've heard that. I want,
And the reason it's in there is it has to blow and ionize
Three is like contracting.
air enough apart to where the arc won't restrike.
Yep.
There's quite a bit of interesting construction to a fuse, because it's not like a fuse in your radio.
Yep.
They're quite different, because once the arc starts, then you've got to extinguish that ionized air. And at 7,000 volts, the voltage comes across 0 and it starts back up the other way faster than the air has time to deionize, but it stays ionized.
Mhm. A lot of times they'll put sand or some sort of chemical in there to help extinguish the arc also. But anyways, the case I mentioned, they're in a Richmond plant. It was a 10,000 volt line. Now, think in terms of putting up an antenna tower that might hit the line. You've got more danger there than just the guy holding or trying to get the thing up. You're going to put a tremendous amount of voltage in the ground. And a sad instance, I don't think I have the card anymore, but I got a QSL card from a guy, and I think it was less than a week later, I read about this person getting killed putting up an antenna tower. It was from this guy I just got the card from. And I looked up the newspaper article, and it was not him, but it was him and his son, while the wife and family were watching.
Oh, God.
Yep. And again, just like that truck, the antenna tower is a wonderful conductor of electricity, and it's not the person right at the antenna tower, but it could be someone close to them.
Yeah, exactly. That's why you don't get it under a tree during a lightning strike.
Yeah,
Because
and
the trees don't protect you.
no, and actually, we'll look at a little more of that. Again, cattle in the field. Again, you got a tremendous amount of potential difference between, let's say, the front half of the cow and the back half.
yeah, their feet are too far apart.
The feet are too far apart. And guess what? You got roast beef.
It becomes an utter disaster, I'll tell you.
And,
Oh, my gosh.
some of them may survive if they are standing tangential to the lightning strike.
Exactly.
Yep. And when I was working on this thing, I happened to flip back onto the internet and I ran across this article here. 1998, there in the Congo Republic.
11 of them.
And anyways, lightning struck the field. It killed all the members of one team, and it didn't hurt the other team.
Shoes.
That's one way of winning.
It's one way to win. And, they felt it was maybe black magic, witchcraft or something like that. It turns out that the team that got killed had metal plates and the other team had plastic.
Right, exactly.
Wow.
And here you thought it was divine intervention.
Divine intervention. And, in the news, we had a couple hunters that died
Yeah.
recently,
Yeah.
again, due to a lightning strike. So what is happening there?
So they found them next to a tree that was burned, but they didn't have burn marks on them.
No, there was no trees
Get-
at all.
And the tree behind them was burned, that's why they're.
I heard there was no trees immediately by them at all.
Well, anyways, again, if you're up in the mountains and there is a potential of a lightning strike, keep your feet together. Because again, the potential difference between 1 foot and the other, and things may get more warm than just crapping your pants.
Yeah, exactly.
And
Stand on the road,
yeah, and
because it gets, I only have that once, but
Stand on your what?
your rope. If you're carrying a rope and you're doing a climb of
Yep.
of a peak, a 14er say, which is what I was doing.
Yep.
And it starts to strike, and it's going boom, 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 you can watch it.
Just stand on your gear, stand on your rope.
yeah, exactly. A pack is even better.
Yeah, rope.
Oh, I see, just to try,
Stand on
Yep.
some insulation is better than no insulation.
Exactly.
Exactly.
And again, you look at the conductivity of rocks, the lightning will actually sheet across from rock to rock.
Yeah, exactly.
So anyways, just a little bit there, what lightning can do, obviously you saw what a 10,000 volt line would do. You look at lightning, it gets even worse yet. Again, straight from the internet, average lightning strike, 30,000 amps. And that's a typical figure. As many as, between 1,000 and 10,000, 100,000 amps. That's a lot of power.
Could that be caused by the ground conductivity in the area where the lightning strikes?
I think that's part of it. Because again, do you meet the open circuit voltage of the lightning strike? So again, you got an impedance matching deal. So let's look at some grounds here. Minimum ground wire, according to the National Electric Code, is number 6 copper. 0.4 thousandths of an ohm per foot. And anyways, at 30,000 amps, you got 75 volts per foot on that wire, not including inductance or anything else. If you look at number 14 wire, essentially it's 2.5 milliohms per foot. And a lot of times, if I need to measure some high current, I'll actually take a 1 foot piece of number 14 wire and measure the voltage across. It worked great. And in this case here, if you got a 10 amp load, and essentially you measure essentially 25 millivolts across the wire, you've got a high current shunt. Oh yeah, feel free to get up, get coffee, whatever. Well, anyways, just to get a rough estimate. What I did was I said, well, what happens with my ground conductivity? Typically, the charts say I should have about 5 millimos per meter. And so I said, what about 2 foot from the antenna? Let's take a cylinder that's 1 foot thick and 8 foot deep, because I have an 8 foot ground rod. And I'm going to impose that 30,000 amps across it. And so anyways, comes out to about 0.62 ohms. which I think is quite low for where I'm at. And at 30,000 volts, you've got 18,000 volts across that 1 foot span. So keep your feet together. The other thing which I found very interesting, and this was in Compliance Magazine, and what they were looking at is ground rods and that, and it turns out that for short ground rods, they're mostly capacitive. For long ground rods, they become inductive based on the RF that's in the strike. But anyways, here is the data, and I'm sure it's calculated data, probably by finite element analysis and that. And based on the conductivity, or actually in this case, the resistivity of the ground. And notice we've got a 10-meter ground rod, so about 32-foot ground rod, 5/8 copper.
Meter?
What's that?
Where do you get one of them? Where do you get one of those?
Good question. They might brace a bunch of copper pipe together. I don't know where they got it. But
They make ground rods that are threaded on the end. And then you have a little coupling, you screw them together.
Yep.
You pound it in and screw another one on, pound it in.
But anyways, these are voltages that are calculated based on a 12,000 amp strike. It's maybe almost a third of what a normal lightning strike would be. The voltage at the strike point there runs somewhere between almost 100,000 volts to about 10,000 volts. And at this point right here.
Now, what do they mean for the bottom of the rod, to the top of the rod?
Well, actually, this is from, okay, it's the voltage based on some sort of reference point at the lightning strike. At the rod itself, it could go up to 100,000 volts, or almost 100,000 volts.
That's in the ground.
What's that?
That's in the ground.
Yes,
Distance from the lightning strike to the ground.
yes. Yep, absolutely. And so typically, I think we're somewhere in this upper part here. And we obviously do not have a 30-foot ground rod.
Yeah.
So
I
what
have a
is,
little 8-foot ground.
what is rho there?
Okay, that is resistivity of the soil.
Okay, that's what I would, okay.
In Mo's, right?
Yeah, I think that was, no, actually, this is ohms per meter. I was gonna say the conductivity is millimhos per meter, which is the standard. So look at the kind of voltages that you have here. And so these voltages get scary.
That's just judging moves.
Gee, you wanna put up the beam?
No.
I think I've changed my mind.
I never even painted the Bailey.
When I was-
Hit once.
What's that?
I worked in 1999 that summer with NOAA,
Mhm.
contract scientist in the environmental technology lab. And our responsibility was measuring storms
Okay,
and how they reacted. And we're looking at the very low frequencies we're talking about, hertz, not kilohertz.
Yep.
And things like that. But what we measured, the average, there is a span in the lightning bolt in the air itself is 1 million to 6 million volts.
Yep.
And you can actually see the difference when you look at lightning. You'll see some very brilliant bright flashes that kind of hurt your eye. That's up in the 5 to 6 million volts. If you look at another bolt of lightning that Okay, you see, yeah, that doesn't look as powerful. That's down below about anywhere from 4 to 1 million.
Yep.
Volts.
And where does it go?
Yes.
Any place it wants to.
Well,
Yeah,
what
exactly.
we also knew too was that you could have a storm 15 miles away from you. And you could have a lightning bolt, what they call clear air lightning,
Yeah,
that
exactly.
can strike 15 miles from the actual cloud source.
Yeah.
And that actually happened in 1979 in May to me when I was living in Arvada. And there was a storm in Golden, it was 15 miles away from me.
Yeah.
And I saw the storm coming, way off in the distance over Golden. I says, well, I'm gonna coil up my antenna cable. So I unhooked everything and I was pulling it out. And all of a sudden, I can tell you, do not hold on to that cable when that happens. I don't know if you've all heard this, but it goes zoom, bang. And it's the conductor between the shield of your PL-259 and the center post. Beautiful, brilliant blue arc. And it snaps, crackles, and pops, and explodes. It doesn't shatter the thing, but it's a bang. And it hit me twice within 5 minutes because after the first shock, it scrambled, my brain other than normal.
Yep.
And so I had picked up that cable again.
Oh,
It's gotta be dead.
Bang! It did
Oh,
again.
wow.
Yep.
It's
And
good
I
you're
tell you
still
what,
here.
folks, it hurts.
It hurts a lot.
Every muscle in your body contracts instantly from your head to your toes. And it's not a good feeling at all.
I had a similar kind of thing, but I'll catch that a little bit later. Let's look at, oh yeah, Mark.
Just one quick comment. Bill N0CU said when that coax is sitting there, put it in a jar.
Yes.
It might help.
That's what I was reason I was throwing it out there.
Right.
Okay.
And again, we'll bring that home a little further yet. Let's take my, let's take my vertical antenna, 50-foot antenna that used to be a 70-foot tower.
Yeah.
And that's when I got hit by the lightning the 4 times. It was with the 70-foot antenna tower. But basically it's 200 foot from the house. And that's about 60 meters. So according to this chart here, 60 meters from the lightning strike, looks like anywhere from 10,000 volts down to maybe 2,000 volts. And that is due to the ground conductivity, etc. But it's worse than that. Going from this ground to this ground here, let's say it's 10,000 volts. What is the voltage on the field of our coax here? I'll go back to this one here. It could be as much as 100,000 volts. So, guess what? You got maybe 10,000 volts here and 100,000 volts coming in here. What if you had a rotor cable up there at the very top? How many volts might you have on the rotor cable and getting back here into the house? I think you start to see the dilemma here.
I isolate my rotor cables with a relay.
Yep.
But those contacts are probably 10K. at the most,
Yeah.
that
And
really is worthless,
well, not really.
maybe for near
Yeah.
misses.
Yeah, what it may do is it may weld the contacts together.
Yeah.
And again, if you weld the contacts together to ground, but which ground is gonna be the most effective here? Do you want the 100,000 one, or do you want the 10,000 volt point?
Belt.
So what do we do?
There's no good answer. It's why lightning protection is basically an art.
So we get insurance.
Yeah,
Um,
you disconnect your radios.
Grounding the antenna next to the antenna would theoretically cut down the amount of high voltage that you could potentially see back towards the house. So having the ground there is a valid point to help out the situation, right?
Yeah, at least it'll help with the differential from top to bottom. I always ground my coax here, they're at the base of the antenna. So again, that base could be easily 100,000 volts.
Well, then that also means that the placement of your antenna relative to your house, if you care about your house, and people in it. Trying to get as far away as possible from the house.
But you got the greatest voltage differential, from the ground conductivity versus this heavy conductor, which we call coax. 6 of one, half a dozen the other.
Hmm.
And so, again,
I was thinking about if the lightning say strikes your 50-foot tower.
Yep.
And it's 10 feet away from the house.
Yep.
That means that the voltage potential inside the house is gonna be much higher than if it was 100 feet away, right? Theoretically.
if you look at ground conductivity, but if you look at the coax as being a conductor, it could be even higher than that.
Would burying the conductor possibly help?
Actually, this conductor is buried about 6 inches deep, all the way out to the tower.
Oh, it is buried, your hard line is buried.
Yes, yep, yeah,
So my thought from that is, on at Jim Morbeck's place with a new antenna, we should ground, make sure we have a good ground at the base of our building, of our towers. And ground, the coax there.
Yep.
But we should also make sure that outside of the building, we have a bunch of relays that normally go to ground.
mhm,
We automatically shut off somehow. If there's any lightning around.
Yep.
To keep it from getting back into the rig, and that should ground all the lines from the road west and.
Yeah, that's what. Conducting it back into Jim's building there.
yeah, and essentially you want to have a ground right here. But again, what happens with all the other grounds and the voltages induced? And what is the voltage induced with your coax? Now, again, you can take it out of, you can disconnect it, you put it in a jar, but
It's hard to do on a remote.
it's hard to do on a remote. And again, your 10,000 volts or whatever, it probably doesn't care, especially if it's a damp, rainy day.
But we do have a double rail insurance.
Yes,
You
And-
need church out there.
and that may be one of the best things,
Yeah.
is the insurance.
Yeah.
The other frightening thing is, again, okay, we got our 10,000 volts coming in here. And that is connected to the radios, which is also connected via the 3-prong plugs and everything else to the breaker box, which can go out to all these wires here. We also have this in the a water line, which can come up here again, get into the breaker box. The power can go most anywhere.
So are the mobs and outlet strips any good for anything?
It'll help,
You,
but
you do think it'll help even if it's an outlet
yeah.
strip way out there and you get a big voltage drop across it, so you get the ground floats up or
Yeah.
whatever. Does that damage the radio, you know? And
no, well, actually, only once have I had my radio damaged. And, a little bit like Jim was talking about, a lightning strike can come out of nowhere.
Anywhere.
I'll never forget, it was just after I built the house. And we had a rainstorm. It cleared, it went way to the east. And I noticed my eave trough was leaking. So I got the step ladder out and I was hanging on the eave trough. A lightning bolt came from somewhere way out east and struck the antenna tower. And I was like hanging on an electric fence.
oh,
And my wife comes out mad as hell. What did you do? You knocked out the television and the lights went out.
Pull up the line.
in the meantime, there's a skeleton hanging there on the side.
Jack. Skeleton. You too.
Yeah.
Oh my God.
And I remember specifically, she was watching a Bronco preseason game. And really, really bad.
Well, at least she has her priorities right.
Ronnie, why don't you come out and hold the gutter for me?
Yeah. Gee, you wanna hold the ladder?
Yeah, ladder, yeah.
But anyways, the feel again was so strong, that it was like an electric fence.
Yeah. I really like that. How
Uh,
bad were you hurt?
what's it?
How bad were you hurt?
Just a little upset and shook up. And what happened to my radio stuff?
Oh,
So
yeah.
did you
what
get
happened?
shocked?
Oh, yeah, it was a good shock.
And you didn't lose your grip or anything.
Oh,
Wow.
Again, I think it almost froze me.
Yeah, I was just
Oh,
exactly.
yeah, when you get lightning, that voltage, it
can't- It doesn't do this.
it doesn't do this, it constricts your
Yeah.
muscles.
Yeah.
So
Exactly.
anyways, that was one experience there, and I think you can see where it is not simple. You got the ground, you got ground potential rise, creating voltages in the ground, but you also have your coax conductor and all your other stuff that is again brought in the house. And it's no problem for the current and the voltage to come up through here, through the plugs and everything else, and now through your entire wiring system.
But you're also, because of the high voltages involved here that we're talking about, aren't you gonna have a dielectric breakdown in the coax too?
You might. You might. Actually, I had one lightning strike, when I had the 4-element 20-meter monobander up. And I don't know if you guys still have it or not, but if you look at the SO2, 239, the face of it has been ground off. A lightning strike basically completely blackened the end of it.
And
What
it
did
would,
it do to your well?
That's another good question. And I did a little work for one of our divisions. It was the Buckner Sprinkling Company that works on golf courses. The biggest problem they have is lightning
I
strikes.
know, exactly.
Yep.
Exactly.
So I think you're starting to see what might happen here
I know.
and the dangers that are there.
No metal cleats in the golf course.
No matter what,
Where's the metal cleats on the golf course?
yeah.
Yeah, like the soccer players.
They
Yep.
eliminated it.
there's a reason for graphite shafts.
Yeah, exactly. What
Yeah.
about steel shafts?
Yeah. So anyways, that was one strike. The hardest strike I took, again, a similar kind of thing. I was working on essentially a panel display. I had a couple computers up and running. The dog was laying underneath the one of the benches or actually one of the desks. And again, lightning strike the dog has been scared of lightning ever since. But on one of the metal credenzas, I had a black spot about that big as it leaped from credenza to credenza.
Exactly.
And the only damage it did to the K3 is, according to Elecraft, I vaporized a line and burned out a transistor.
What?
And they repaired it, did a full alignment of the K3 for $175,
Wow.
That's a
Which-
good price.
which I was very pleased with.
Yes,
That's for sure.
Now they won't even crack them open for less than 250, so.
yeah, exactly.
Well,
Was the transistor the TR switch?
what's that?
Was the transistor the TR switch?
No, actually, it was in the keyer. So somehow it went from the keyer up into one of the wires and then back into the radio.
Okay.
So it goes pretty much anywhere you want it to.
It wants to.
Yeah.
It wants to.
Yep. So anyways, some more open discussion and we're starting to finish up the hour. But again, what happens at my station, we talked about it. Think about your stations. Jim, think about the remote station. Yep. And the absolute best ground you can have there at the tower is multiple ground rods. Let's go back up here. Notice how much voltage we got here. If we can have a good ground out, let's say 10 meters or something like that, it takes care of a lot, a lot of this voltage here.
Is there some reason for that knee at 20?
Yeah, it's,
Yeah, I think it is. And I believe
Is there
this,
some reason for that? What's the,
I think it is the depth of the ground and again, fanning out, going deeper underground, which gives you more area, which is more conductivity. I think, I don't know. I didn't spend a huge amount of time in the article. Yeah,
Well, that antenna on the Jim's place is well, the support is well underground.
yes,
So you probably wouldn't need ground rods, would you?
You would, because it's galvanized.
Yeah.
So it's got a resistance to it. So you'd be better off putting ground rods by.
yeah, actually, the better ground you can get, the safer you're gonna be. I'm not sure how much it's gonna help.
So
And I'll
Larry,
bring 'em.
for the ground rods on the remote station. How many would you recommend?
Yeah.
And how far from the tower should we put the ground rods? And because we wanna mow out there, I mean, it's ag country. And it grows in the spring, believe it or not. And so we mow. So can we bury those ground lines and bury the posts so the mower can go over it without?
Absolutely. And, in fact, that's the best way to put them in.
Okay,
And they're not gonna get mechanically
how far
damaged.
deep do we have to go?
how long should the ground rods be?
Well, again, 8 foot is
If you buy.
easy to get. Longer the better. The deeper you can bury the wires, the better. There's no good answer.
Do you need to worry
Yeah,
about
cause we're talking
corrosion?
about money when we start renting equipment to trough
Yeah,
and things like this. So we'll figure it out, yeah.
Yeah,
so what about corrosion? Like you've got to connect to
Sorry,
the
what?
ground rod, it's gonna be underground, how big's the conductor need to be back to the tower? How do we connect it?
when you buy these clamps for your ground rod?
Yeah.
Some of them will say they're variable.
yes,
Are they supposed to be encapsulated in
nope,
epoxy or something?
nope.
So aren't they gonna corrode away?
Yeah,
under the-
that's-
Copper.
Yep,
Well,
and
they're bronze.
which is a form of copper and it should not corrode. And don't solder any of your wires that are going to be buried in the ground because because the the solder will corrode and go away.
But just hammering in a ground rod and putting those 5/8" bronze clamps.
Yep.
And
We
cover
have
it with dirt.
several 100,000 of those in public service.
Probably fuse if it's.
So how far away from the tower
Yep.
do you recommend,
Well-
closest to the tower or at a specific distance, or what do you recommend?
The ground rod has like a 6-foot radius of effectiveness. So if you have another ground rod, you want it at least 12 feet away, or you're wasting, you're.
Yeah, but if you had a tower from the point of the base of the
Well, that's a
tower,
ground rod.
are you talking ground rods in a circle around the tower?
About
If you
13
can,
About 13 feet away,
That's
About
the risk you wanna get.
yeah.
About
I did that-
13
Yeah,
feet
Gordon.
away from the tower?
Jim, around the base of my tower, I did a wagon wheel
Okay,
with a 13-foot radius. And I have like 6 rods around. And
okay.
they're all, each of the rods has a number 4 to the base of the tower, and then a number 4 connecting them this one.
And how'd you connect them to the tower? Did you use a plate or something, or?
Bronze, no, you get a bronze clamp
Yeah,
for, like 1.5 inches.
and you just put it around the leg of the tower?
Yeah,
One of the talks we had in the past, the suggestion was you put a grid, you buy fence wire or whatever, and you put a grid at the bottom of the tower and connect it to the tower as best you can. They said, well, about like 6 feet, at least 3 feet out, and then you connect the your ground radials to that. But that was what they said to do a couple of the talks we had here over the past 10 years. And they showed this whole grid, you put it right down, right at the tower, connected to the tower as best you can, and then go out from that grid you put down there out to the different crown lines. What they said was the best thing to do.
yeah, I think, yeah.
To your point, Jim. Burying, the lightning rod.
I'm sorry, what?
To your point about the grounding rod,
it's like.
Yeah. bury it horizontally,
So, yeah.
or drive it into the ground.
Tower.
If you're not gonna use a trenching tool, it's always gonna be better to drive it down, I would think.
You have.
Because the closer you get that grounding rod line horizontal to the surface, it's gonna be much more affected by things like the rain, if the ground dries out, the conductivity is gonna change. But you're always gonna have a better, I would imagine, a better conductivity path. Generically speaking, by driving the stake in.
Yes,
in
yes.
the ground.
Vertically. Yes, yes, absolutely. I believe the NEC says that if you're in rock, you can bury it at a 45-degree angle.
Because like. And.
Yeah. mhm.
How deep?
What? Oh, I think starting at the surface, 45-degree angle, stick it in. Either that or drive it
Okay,
in.
well, we were talking about burying the wire going from the tower to the
Okay.
ground rod.
Yeah, being your
And
soil,
then you're talking about doing 45-degree angle. I knew about the conductivity. The more horizontal you can get that wire, but
I've heard of some people in installing grounding rods by just burying them and laying them horizontally. And
Yeah.
Based on what we discovered here as far as effects, that doesn't sound like a good way to go.
Yes, it is not the preferred way to go.
if, I was gonna say, if we can drive them straight in
Yes.
Strasbourg, probably, soft soil.
Yep.
Well, I know, you'd know better than me, right?
Sorry.
Yeah,
Yeah.
Once you get enough Gatorade on it.
yeah, right, May,
Month of October.
yeah.
And-
May.
And again, I would strongly recommend grounding it just before it goes into the building.
Well.
Yeah, George?
Like to know, does anybody know the commercial product for rotors that you could put outside of your house? And when you bring it over, it would normally ground everything there, and then if you have any power inside, which would run the relays. But it would ground it outside until you put the switch or something to those relays. Does anybody know of a commercial product that's made to do that? Or do you have to construct your own?
For what product? For what? To do what?
For the rotator. It's
Oh, for the rotator?
Lines coming in.
Well, Polyphaser makes a little box for $100. And I took the top off and they're MOVs.
Mhm.
Okay.
You gotta get the right voltage and, you know.
How many lines are there on a rotator control these days?
6.
6?
That's what,
Well-
don't we have 6 on ours? On the Yaesu going in?
Where'd it come?
Yeah.
It's got,
It's 6
not sure.
on the rotator, on the Aldas, and
Because
I'm running 6, so that's probably.
Does that power the rotator too?
But they changed from DC.
Two 18 gauges.
About 5 years ago, they changed from DC to AC.
Okay.
Couple of wires aren't used anymore.
Oh, okay.
And I don't really remember.
Okay, I think I had a question.
You haven't talked at all about gas tubes between the
Mhm.
center conductor and the shield.
And
At both ends, I have my antennas, I've got center conductors protected the ground through
Yeah.
gas tube, and then also before it even comes into the house at that end also.
And again, what those gas tubes will do is at least limit the voltage between the center conductor and the shield.
Right, but if
And
you don't have anything there at all,
okay, what I've done is I've got a series of relays, and so it's tied into the off-on switch of the radio. And so whenever I'm not using it, it takes the center conductor and shorts it to ground outside the house.
That's what we're doing at the remote.
antenna. What
And
about
what is
the
it?
antenna?
The antenna, I don't think there's much you can do there. You know, again, you could do the same thing.
Some gas tubes out there.
Yep. And then again, every little bit helps. And how far do you want to take it?
So you, whenever
How
you're
expensive
done with the
do we
radio,
want
you
to
turn
go?
that switch and it's off.
What's that?
Every time you're done with your radio, you turn that off and then it's disconnected.
Well,
Good
now,
idea.
Our remote station does.
again, it does not disconnect
It's always
the
a-
coax,
Yep.
but it disconnects the center conductor and shorts it to ground.
Sure, okay.
And so that is reasonably safe, and you just don't turn it on when there's the possibility of
Like you're
lightning.
not like, driving to the airport with a bad storm at home and like, oh crap, I left everything on. You know, or you could be, my next thought was, I'm remoting into the station that's even east of the airport. And there's no lightning out here in Lakewood, but how do I even know that there is one, superstorm flying over Strasburg? Unless I've got a webcam, like looking out at Jim's house.
Well, you know, because you're seeing the ground.
Well, yeah, if you're actually using the station, but if I'm like,
Yeah.
Oh, I mean, remote,
yeah,
and you're seeing the ground floor.
Yeah, you'll see the pan adapter bounce up and down
Oh, sure.
with
I'm
lightning
just trying
strikes.
to avoid that, like, if I'm gonna remote into it. Oh my God, how do I know there's a storm out there? Should I be the one that flips the relay off, so. Or to leave it off?
If you're seeing the noise or do that.
Yep.
Those are,
Lightning crashing nearby, yeah.
Larry,
Yeah.
You should go.
you mentioned just a minute ago that we should be connecting a ground to the house. From where to the house? Actually, to the Radio Shack, or the lab building then.
Again, I would have this box here well grounded, at least trying to protect the house as much as you can. Yeah,
The only reason for grounding is to keep the potential off of it, because lightning strikes from the ground up, doesn't go from the cloud down.
Exactly.
So what you're doing is keeping the potential off of that rod, so you don't get a lightning strike.
Mhm.
Is that correct?
Now there's some of that, and I think that's one of the reasons that, I got hit. I got hit so many times over here with.
You have a bleeder resistor in your verdict?
No,
Have you thought about that? I mean, did you rule
Yeah.
that out for
Yeah.
a reason?
yeah, I should, although it's base loaded with a coil, and so that would act as a bleeder resistor. So anyways, it's a tapped coil.
When you're on the air and the storm is 5 miles, 10 miles away, are you seeing a discharge like that?
I haven't recently, but when I've had other antennas up, you hear sort of this bang,
Yeah,
and the noise goes away. And most of the time, that is wind static. Static being built up on the antenna due to the winds blowing across it.
so do you hear that on your vertical?
No. And again, I have a base loaded coil here, goes from the antenna to ground, and then it's tapped.
So it's really a DC,
Yeah, so you do have a DC ground at
okay,
that
so
point.
you don't need a bleeder.
No.
Okay.
Yeah, George,
One trick for everybody, if you build dipoles, put 100K resistor across the center between the two ends.
If there's not
Get
already a
rid of
DC
that
fan.
differential between the two sides. And that way it'll keep it from sapping.
We got a lot of final thoughts.
Yeah.
right, and
Be here till 2 or 3 in the afternoon.
yeah, and it's one of these things where, with this talk, I don't think I answered very many questions, but I sure raised
You
them.
sure raised some.
Yeah.
You raised the ones I was hoping you were gonna answer.
Right,
Yeah,
and I can't answer those. It's your choice.
So you're talking about static building up on the line, and one of my projects I wanna try is to do a kite antenna.
Oh,
Where
yeah,
I'm flying like an end fed off, hanging off of a kite. And I've got all the stuff to do it, except what I don't know is, what am I supposed to do at the ground where I've got the end fed matching unit? And then do I just like tent peg a radial into the ground so it's static bleed? Is that
Yeah.
gonna be enough? I mean, I wouldn't do it in a storm, obviously,
Yeah.
otherwise it'd be the Ben Franklin experiment with the key and,
Yeah.
so I kind of want to do it on just a breezy day over by the park by my house and try to fly a kite. But I've got to stake something in the ground, right, to keep the end fed matching happy.
no, actually, with your end-fed antennas, if you got the right matching thing,
Yeah.
it works just fine.
Okay,
And typically, the other half of the antenna is the coax feeding it and the radio and all this other stuff.
so I'm not really worried about building up static on the kite line then?
No,
Okay,
no, again, you would hear it before it's a problem. It'll be this buzzing noise that gets louder and louder, and then you'll hear a snap.
and hopefully you get to hear
Too
it.
late, I guess, right, yeah.
Yeah.
So maybe don't plug my $1,200 heat into it, but.
Like yours.
Okay, we ran out of time.
I had a question about your relays. Does that bother your SWR?
No, no, actually, it's one of these remote antenna switches. Which I mounted in the box, and so the normal position is closed. And I have to power it up then to actually have it.
And what brand is that?
I don't know. It's some sort of. It's a piece of crap I picked up.
Yeah, that's great.
Typical amateur stuff. Okay.
Larry, thank you.
You got us thinking, Larry.
Thanks for all the comments too.
Yeah.
That was,
That was really
Yeah,
good.
I couldn't find it.
Yeah.
Renew my insurance.
It's the right color.
Got the lighting breaks out there.
Oh, we're gonna, I've done. But I've never tried that.
Yeah, Google, BIA